So we will continue with the functions. 4 point. So 6 point, right? 6 point. 3 polynomial and exponential functions. So first of all, can you remind me, Ilham, what is a function? What is a function? Yes, Yora?
It's a relationship between variables, independent and dependent.
Yes, dependent and independent variables. It's all about relationship, right? Function is a relationship. Before that, we have covered with you guys linear functions, right? Which has x on the power of n, where n equals to 1, it becomes linear. When n equals to 2, it will be quadratic, right? And etc. Today we will cover n equals to 3, okay? X on the power of 3, it means cubic. And today we will cover n equals to minus first power 1 over x, okay? Or let's say we will change its form in general, we'll cover it, okay? This is called hyperbolic, right? Hyperbolic. And it's cuboid, okay? Cubic one. And we will cover some exponential functions. Before that, we have covered operations on exponents itself, not functions, okay? And we will try to cover exponential equations, inequalities at the same time, okay? So, have you understood the agenda of this today's lesson? So, y equals to x cubed. First of all, let's define the domain of this function before graphing it, okay? What is the domain of this function? Is there any restriction for our x? So, is there any restriction? No, right? So, it can take any value. What is about range in order? Any value, right? So, the same. From minus infinity till infinity. How to draw? We use the table values, right? You give values to x and find respective values of y and find the relationship graphically, okay? X, if it equals to 1, it becomes 1. If it's 0, 0, minus 1, minus 1, okay? 1, 1, 0, 0, minus 1, minus 1. But these points are not enough because it is the same with the linear one. Let's give another point, minus 2, 2. Okay, to make our graph much clearer for you. Minus 2 cube is minus 8. 2 cube is 8, right? So let's draw 42. 1, 2. Till 8, let's say. Here you have minus 8. Something like that. So this is your first cuboid graph, okay? Y equals to x cubed. Let's say it's y1. So let's compare this graph with y2, okay? y2, where your y2 equals to twice of your x cubed. So here your coefficient was equal to 1, right? Now it has changed to 2. So how will it affect your graph? The first 3 points are the same, right? No.
2.
If you're giving 1, it becomes 2, right? And here it will be minus 2. What about the rest? Minus 2 on the power of 3 is minus 8. You just multiply your y1 results to 2, right? The only coefficient that you have. It's gonna be?
Minus 16.
And? 16. So for 1, now here you have 2. For minus 1, you have minus 2. And minus 16, 16. Something like that, okay? So, both of them are increasing function. Yes? Do you agree? When your function increases, Ilhan, increase in your x variable, independent variable, cause increase in your dependent variable, or decrease in your independent variable causes decrease in your dependent variable. We have covered it in the first topic, right? Before covering linear functions, we have covered some definitions, some terms on these relationships, right? So is it increasing function or decreasing function, this function? X cubed.
Increasing.
So you can take any 2 points. Any 2 points. That's x1, that's x2, y1 and y2. Increase on your x causes increase on your y2, right? Saying increase causes increase. So it is increasing function, okay? Yes. Is that function odd function or even function? Odd function. How did you define it?
It's y equals to 8x.
So you replace your x with minus x, right? minus x, and your result is minus x cubed. You are releasing the same original function with negative sign in front of it, right? Or you can show it graphically, say that it is, yes, it is symmetrical with respect of origin, right? 0, 0. You can fold it, it will be on top of one another, both of these functions, okay? Have you understood it? Okay, odd, increasing. This function, I mean your y2, is increasing faster, okay? Change in your y is greater than change in your y1, okay? This triangle stands for the change. Change in y2 is greater than change in your y1, meaning that this function, both of them are increasing function, but y2 is increasing faster, okay? If your y3 equals to 1 over 2x cubed, so you give the values, they are half of your y1, right? y1 divided by 2, 0.5, 0, minus 0.5, minus 4, 4, and you draw it something like that, okay, let's say. So this is y3 equals to 1 over 2x cubed. This function, change in this function, is even less than your y1, okay? This function is also increasing, but it will increase slower than your y1, and y1 will increase slower than y2, even though it is increasing faster than y3, okay? So faster, slower, slowest, okay? Have you understood it? So let's compare x squared in this case, okay? y2, x4. So this parabola, right, x squared, this is function graph of the parabola. 4, 0, 0, 4, 1, 1, 4, 2, it is 4, and gets the same value for minus 2. Minus 1, it gets the same value as 1. x4, xy, if you give 1, it's going to be 1 on the power of 4. If you get 0, it's going to be 0, minus 1, 1, 2, 16 minus 2, 16, right? It is even function. Both of them are even functions. If you replace your x with minus x, you get the original function, isn't it? Yes? X on the power of 4. So here you have 1, 1, 0, 0, 1, 1. But will it lie something like this one or this one? Inside or outside? You have to give further points from 0 till 1. Let's say 0.5. If you give 0.5 for y1, what is the value of this? It's 0.25, isn't it? If you give for y1 0.5, it's going to be 0.5 on the power of 4, meaning the 0.25 squared, right? Which value is greater? Of course 0.25, right? So it will lie below, okay? Something like that. And the rest will be up high. So it will be below of this function and then up high, okay? So let me use other colors. Have you understood, students, how it looks like? The graph of this function. Yes? It is much closer, I mean x2, y2, right? y2, it is y1. y2 is much closer from my minus 1 till 2 in x-axis, right? And your y1 is closer at that interval for your y-axis. But it gets further away if it crosses a line, cross the interval that's greater than 1 or less than minus 1. It will go further away than your y compared with your y2. Okay? So here your function is decreasing function, right? Both of them. And here it is increasing function. That's from minus infinite till 0, it is decreasing function. From 0 till infinite, it's increasing function. So, but what about their change in their increases? How they increase? You can see that your y2 from minus infinite till minus 1 is increasing faster. Yes? y2, right? x4 is increasing faster. But within the interval from -1, not increasing but decreasing, right? Decreasing faster. From -1 till 0, your function x4 is decreasing slowly. Yes? Your x2 is decreasing faster. Yes? And from 0 till 1, your y1, x on the power of 2, is increasing faster than your x4. But from 1 till infinity, your x4 is increasing faster than your x2. Okay? This is just an analysis of your graph, how they increase or decrease. Okay? If you understood it, let's continue with our polynomial function. Y equals to ax cubed plus 5. So, we don't know your a. Let's say it's minus, okay? Because we have covered some numbers with plus. First of all, if it were without negative sign and without 5x cubed only, how will it look like? So we have already drawn it, right? Now, it will take negative values. Something like that, okay? This is minus x cubed. Y equals to minus x cubed. What if you add 5 to all of the values of y? It will go 5 steps up, right? And it will be something like this one. Where will it cut your OX axis? It cuts OX axis when your y equals to 0. Minus x cubed equals to minus 5, x cubed equals to 5, and your x equals to cubic root of 5. So this is, can you give me an approximate value? Cubic root of 5. So which number, if cubed, will reach to 5? Juntos? Yes? Is it greater than 2? Yes? No, it's not. Because if you had 8, it will be 2. It's still 2, between 1 and 2, right? So somewhere here. So, if it were minus 5, minus x cubed minus 5, it will go 5 steps down, okay? Something like that. And if it were minus 2, it will shrink, okay? Something like that. It will shrink. Because here you had y2, 2x squared. If it were minus 1 over 2x cubed minus 5, so you have already drawn with minus x cubed minus 5, you just enlarge it because you're adding minus 1 over 2. Okay? The domain will not change, but range will change. Okay? What is the range of this function? We know the domain because x can take any value, right? There is no limit. Will it change actually? Students, your y, will it change? Your range. Malika, what do you think? No, it will not change, right? Because is there any limit that your cuboid will not cut point of y? Is there any point? No. Your function, if you continue of course, will continue in all of your y's. Okay? So there is no limit for x and y. It means your range will not change. Okay? If you understood polynomial functions, okay, copy them. We will cover hyperbolic and exponential. Is it easier, guys? Now easier, right? Is it easier? Okay. Yes, Iskandar? Okay. Done? Can we erase it? Can we? Ilham? Farangis. Okay. We will continue with hyperbola, okay? Hyperbola, hyperbola, superbola, right? Hyperbola. Y equals to, we have told you that hyperbola is x on the power of -1. So let's take 2 over x. How will you draw the graph? First of all, let's look through domain. Let's look through range. Let's define whether this function odd function, even function. So what is the domain of this function?
X mustn't be 0.
Yes. It means x mustn't be equal to 0, meaning that you can't take the value. It is undefined in 0, right? Your x is not defined on 0. What about your y? The same, right? Y should not be. So these two lines are called asymptotas, okay? Asymptota is a line that your graph will approach closely, infinitely close, but will not cut, okay? So let's give table values. Is this function odd function or even function? You can replace your x with x to see, to check, okay? -2 over x, right? You're releasing your x in front of it, so it's odd function, okay? Okay, let's draw it. If you're giving 1, you get the value of 2. If you're giving -1, you get the value of -2. If you give half, you get the value of 4, right? If you get -0.5, you get -4. So here you have 4 points, 1, 2, -1, -2. 0.5, 4, -0.5, -4, right? -1, -2, okay. This is your hyperbolic function, okay? The graph of it. This actually function. Graphical representation of this function. Okay? First you have to do is to draw the asymptotas, and then to be sure you can take values for x and y, give values for x and release the values for y, and draw it, okay? In general form, hyperbolas to be like 2, not 2, a divided by x plus b plus c in this form. So let's take it, y equals to, we have covered a over x, let's add b now. 2 divided by x minus 3. How will your asymptotas change? So you have the asymptote of x3, right? And y should not be equal to 0. Meaning that your asymptote is as follows, right? X equals to 3 and y equals to 0. And you can draw them. Yes? So, will it always lie, if you are drawing your asymptote, will it lie on the first quadrant of your asymptote? And the third one always?
No.
No. It depends on A, right? If your A is positive, it will lie on the first and third quadrant. If your A is negative, it will lie on the second and fourth quadrant, right? Let's look through this example as a whole one, okay? -5 divided by x plus 2x plus, let's say 6 plus 1. How to draw? First you define asymptotes, right? First asymptote is for x.
6.
So, no, 2x plus 6 is not equal to 0. X is not equal to -6 over 2. It's not equal to -3, isn't it? Yes? So, -3 is your first asymptote. Okay? What about the second one? No.
5.
Not minus, but 1, okay? So this fraction can't be 0, right? Meaning that your y can't reach to 1. Because it's never 0. It will be 1 point something or 0 point something less than 1. And more than 1, but not 1. Okay? So your asymptote is y equals to 1. Okay? This y equals to 1. Here you have x equals to -3. And we have told you that if your A is negative, it will lie in second and fourth quadrant of your asymptotas, okay? First quadrant, second, third, fourth, you draw it as it is, okay? What does this value define? 5, here you had 2, here you had 2. What will it define? It defines how close your curve, next, turning point, something like that, okay? This curve close to your asymptotes, okay? If you understood hyperbola and you know how to draw it, right? Is this function, okay, these functions, increasing or decreasing functions? You can look through the values. For lower value, you are taking smaller line, right? For bigger values, you are taking bigger results. Meaning that increase in your x is causing increase in your y. Is it increasing function or decreasing function? Increasing, yes? Okay, if your a is positive, it's increasing function. If your a is negative, it's decreasing function. You can take any 2 points and compare, okay? To be sure. Have you understood? Okay. Let's cover exponential functions. A on the power of x equals to y. This exponential function. Do you have any limit in our domain? So actually, what is the domain of this function? Is there any limit for your x? No, any limit. X can take any values. What about range? What about range? Is there any limit for your y? A on the power of x. 2 on the power of something. 2 on the power of x. It can't be negative, right? So your y takes any values starting from 0 till infinity. It even can't take 0. Yes? We will cover 2 types of functions, okay? This kind of so exponential. 2 kind of exponential functions. First, a, let's say a should not be equal to 1, because 1 on the power of x equals to y, equalize it to 1. This is just monotonous constant function, so no need to analyze it, okay? We will look through when it's less than 1 and greater than 0, and when it's greater than 1, okay? Both at the same time. Let's say your a is 2. Here it's 1 over 2. 1 over 2 on the power of x equals to y. 2 on the power of x equals to y. Let's draw their functions. Giving the values, first of all, creating the table. If your x is 1, 0, minus 1, what are the values that you are taking? For 1, if you give 1, it's going to be half. For 0, it will be 1. For minus 1, it's going to be 2, right? So let's give these points in our curve, in our graph. 1, 0.5 here. 0, 1 over here. Minus 1, 2 over here, right? So this is your function, okay? It can't be negative and even 0, okay? You have several asymptotes that are located below of this line, okay? So your graph will tend to go closer to them, but will not cut, okay, even touch to the asymptotes below of your x-axis. If you have this kind of function, okay? 2 on the power of x. Let's give some values. If it's 0, you get 1. If it's minus 1, you get 1 over 2, right? If you take 1, it's gonna be 2. 0, 1, minus 1, half. And for 1, you take 2. Something like that. Yes? This is 2 on the power of x. This is 1 over 2 on the power of x. So, first of all, is our first function increasing function or decreasing function? This function, is it increasing or decreasing? It's decreasing function, right? What about this part? It is increasing function. Are they odd function or even function? No, they are not symmetrical for with respect of your y-axis, right? If you fold it, it will be somewhere here, right? So, and this line will be somewhere here. It's not even function. They are actually. They are not even function, not all functions. So, meaning that neither of them, neither odd nor even function. Increasing, decreasing. So, have you understood it? Do you have any questions? No questions? Okay, this is just a function. We will cover equations and inequalities and work more on them with our exercises, okay? Copy. Exponential functions. So we have looked through some of the functions, okay? Let's turn to equations of exponential ones, okay, exponential equations and exponential inequalities. We have told you that if your a is between 0 and 1, it is increasing. Yes? No, it's decreasing. If your a is greater than 1, it is increasing function. So, if you are facing 2 on the power of 3 equals to x on the power of 2 on the power of x, what your x equals to? What your x equals to? It is 3, right? X equals to 3. What if you have 1 over 2 on the power of, let's say, x 1 over 32, what your x equals to? No. 5, yes? 5. Meaning that you are just dropping their bases, right? And equalizing their exponents when their bases are the same. The same. In general, a on the power of fx equals to a on the power of jx equals to fx equals to your jx when your bases are the same, okay? Meaning that you just drop their bases if you have equalized, if you brought them into the same basis. What about inequality? For inequality, it changed, okay? So if your a is within this interval, let's say a on the power of fx greater than a on the power of jx, if you have equality, you will have. So your a is between 1 and 0, you will drop their bases, but change the sign, okay? Fx less than or equal to jx. Okay? You just drop their bases and equalize it to this one. Okay? So, what about this formula? In this case, a on the power of fx, let's say here you said greater, let's say less than. A on the power of jx. So you drop their bases. If your a is greater than 1, you keep its sign as it is, okay? So your fx stays to be less than or equal to, if you have equality, then you will have here jx, and that's it, okay? You just drop it. So let's look through some problems for this inequality. Let's start from the 6th one. 2 on the power of x greater than 2 on the power of 3. The base is greater than 1. You just drop him and say x is greater than 3. That's A part. Let's look at B part. 1 over 3 on the power of x greater than 1 over 3 on the power of 3. The base is within the interval starting from 1 till 0 till 1, right? You drop their bases, but don't forget to change their signs. So x stays to be less than 3. From minus infinity till 3. Here, from 3 till infinity. Let's turn to C part. 3 on the power of x greater than 9 on the power of x. So look at the bases. For the first one you have 3. For the second one you have 9, right? So you have to bring them into same basis. 3 on the power of x greater than 3 on the power of 2x. You drop their bases. X stays to be greater than 2x. So you bring them to one side. X stays to be less than 0. From minus infinity till 0. Okay? So you just look to their bases before dropping them, whether to keep the sign or to change it, and that's it. Okay? Let's look at D part. 2 on the power of 9x minus x cubed greater than 1. How can you bring 1 to the power of 2? 1 is 2 on the power of 0. Right? Your problem, your job here is to bring them into same basis, and that's it. Okay? Bring them into same basis. And then you solve inequality or equation by looking at their basis. You will drop them. By dropping, for equation it's the same, okay? Irrespective of your base. But for inequality, if your a, what you are dropping, is greater than 1, your sign will stay as it is. If your a is between 0 and 1, if your function is decreasing function, okay? You change its sign. Now it's 2. Will you change the sign, Ilham, or not? No. So 9x minus x cubed greater than 0. You bring all of them to one side. X cubed minus 9x less than 0. You release x. You are left with x squared minus 9, so it's x minus 3 and x plus 3. Less than 0. You use the method of intervals to solve it. Minus 3, 0, 3. Something like plus, minus. You can take any value and check. So you are asking about negative intervals. starting from minus infinity till minus 3, union from 0 till 3. This is your solution, okay? If you understood it, E part 0.3 on the power of x squared minus 3 less than 0.09 on the power of x. So 0.09 is 0.3 on the power of 2, isn't it? And you have power of the power, so you have 2x. You drop their bases, but what about the sign? Diora, can you tell us? Will you change the sign or keep it as it is? Change it, right? You will change it. X squared minus 2x minus 3 is greater than 0. So x minus 3, x plus 1 greater than 0. We are using factorization method, okay, not discriminant one. Minus 1, 3, plus minus plus. Greater than, meaning you take plus, minus infinity minus 1, union from 3 till infinity that your x can take. The values that your x can take, okay? Let's turn to 7. Solve the equations. It's saying a part 5 on the power of x equals to 125. 5 on the power of x equals to 125 is 5 on the power of 3. So 5 on the power of 3, your x equals to 3, that's it. B part 2 over 3 on the power of x multiplied 9 divided by 8 on the power of x equals to 27 over 64. So what is the common base? You see 2's and 3's, right? So let's bring all of them to 2 and 3 bases, okay? 2 divided by 3 on the power of x. Here you have 3 divided by 2 on the power of, so this is 3, this is 2 on the power of x. Right? Here you have 2, 3. 3 on the power of 3, 2 on the power of 6. Isn't it? Yes. So you have 2 over 3, 3 over 2, 3 over 2 again. What to do then? You bring them into same base, right? So 2 on the power of x divided by 3 on the power of x. Here you have 3 on the power of 2x. Here you have 2 on the power of 3x. Power of the power should be multiplied, right? Equals to 3 on the power of 3 divided by 2 on the power of 6. So there is a cancellation happens. 3 on the power of x. Here also cancellation happens. 2 on the power of 2x. So 3x, 2 on the power of 2x. Let's write from here. 3 on the power of x divided by 2 on the power of 2x is 4 on the power of x. 3 on the power of 3. Here you have 2 on the power of 6. Or you can change it to 4 on the power of 3. Right? 4 on the power of 3. So your x equals to? That's it, okay? So your job is to bring their bases to the same base and just drop and work with its exponent, okay? It was 7b part. Let's look at c part. 3 on the power of x, 3 on the power of x minus 12 plus 27 equals to 0. You can denote 3 on the power of x as t. So your equation changes to t squared minus 12t plus 27 equals to 0. So let's steal that, okay? T minus t. So which number should appear here? So the sum, the multiplication will be 27 and the sum will be 12.
3 and
9 equals to 0. Your first t equals to 3 and your t was 3 on the power of x. First x equals to 1. 3 on the power of x equals to your second t is 9 and your x equals to? No.
square.
2. Yes. How did it become 3? 3 multiplied by 3. Something like that? No. So the second x equals to 2. D part. 2 on the power of 2x minus 5 multiplied 2 on the power of x equals to 24. You just do the same. 2 on the power of x denoted as t. T squared minus 5t minus 24 equals to 0. T minus 8, let's say t plus 3 equals to 0. Your first t is minus, your first t is 8. Your x equals to 2. Your second t equals to minus 3, which means that it is out of this range, right? Out of its range. So empty set. Your solution is 2. Let's turn to 8. 1 over 2 on the power of x minus 4 minus x squared. Here we have 4 on the power of 2x minus 1. So we are only here working with equations here. We have worked with inequalities and work with inequalities further. So 2, you are bringing this expression to the denominator, so the sign of the power will change, right? Minus x plus x squared plus 4 equals to 4 is 2 on the power of 2. Power of the power should be multiplied, 4x minus 2. So the bases are the same. You equalize their powers. X squared minus x minus 4 minus 5x plus 4 plus 2 plus 6 equals to 0. X minus 2, x minus 3 equals to 0. Your first x equals to 2, and second one 2, 3. Okay. Have you understood it? Do you have questions? No? Let's copy. 9, right? 2 on the power of 4x minus x squared greater than 1, and 1 is 2 on the power of 0. So you drop their bases, 4x minus x squared greater than 0, but your base will not change, right? Actually, this is cube, students. If you are taking x out of the bracket, you are left with 2 minus x, 2 plus x. That falls to the formula, okay? 4 minus x squared, 2 minus x, 2 plus x. So, you use the method of intervals to solve. Minus 2, 0, and 2. You can use something like that. Minus, plus, minus, plus. Greater than 0, it means you only take plus signs. Starting from minus 7 till minus 2, from 0 till 2 is your solution, okay? 10. A part. 7 on the power of 2x minus 9 on the power of 2x equals to 6 multiplied by 7 on the power of 2x minus 6, 9 on the power of 2x. So here you can see, here you have 6 times of 9 on the power of 2x, here you have 9 on the power of 2x only. If you are taking it from right side to the left side, you have 5 times of 9 on the power of x to x, isn't it? So plus 6, minus 6 becomes plus 6, and here you have minus 1. So it's going to be 5 times of that number. So if you are bringing it to another side, 6 minus 1 is going to be 5, 7 on the power of 2x. And there happens cancellation. When these two expressions are equal to one another, Nodar, can you tell us? Iskandar? Ilhan? Farangis? No? Malika? No? Okay. Yora? When they are equal? 9 on the power of 2x equals to 7 on the power of 2x. When they are equal? Mumtos? No? Sarunat, what about you? No? Okay, students, when your x equals to 0? Yes? Or you can say 9 divided by 7 on the power of 2x. So you are dividing it to another side. Here you have 1, and your 1 is 9 divided by 7 on the power of 0. You equalize 2x to 0. Yes? You can prove it algebraically, or it's obvious. If you have 0 power, irrespective of difference in bases, your equation will be the same, your expression, right? That's this equation identity. A, B part. 2 on the power of x squared minus 3 multiply 5 on the power of x squared minus 3 equals to 0.01. Multiply 10 on the power of x minus 1 on the power of 3. Power of power should be multiplied. 3x minus 3. So 0.01 is 10 on the power of minus 2. And you can add its power, so it becomes minus 5. Okay? Here you have the power of 10. Here you have same powers, but different bases. A on the power of n multiply b on the power of n. Using this formula, you can say ab on the power of n. So you are multiplying their bases if they have same exponent. 2 multiplied by 5 is 10 on the power of x squared minus 3, because they have the same powers. 10 on the power of 3x minus 5. You drop their bases. X squared minus 3x plus 5 plus 2 equals to 0. First one is 1, second is 2. You sum equals to 3, and multiplication equals to 2 from Viet's theorem, okay? 11. So we don't have 11. Let's turn to 1 from homework. Draw the graph of y equals to x cubed minus 1. How to draw? So we have drawn x cubed, right? We just drop it by 1. Yes? B part. Y equals to x4 plus 1. So we have drawn x4. You just raise it up by 1, right? Something like that. Okay? So second one then. Draw the graph of the function y equals to 1 over 2x and y equals to 2 over x. On the same axis, from the graph indicate the coordinates of intersection points. First of all, your first function is line, right? X divided by 1. It passed through the origin by 2, right? If your x is 2, it's gonna be 1, right? So if x 2, it's gonna be 1. If your x is minus 2, it's gonna be minus 1. So this is your line of first one, okay? What about y2? It is hyperbola. What are the asymptotas, Diora? What are the asymptotas for 2 over x?
0.
Yes, x equals to 0 and y equals to 0, okay? So x equals to 0, y equals to 0. And it is located in the first and third quadrant of your asymptotas because your A is positive, right? This one and something like this one, okay? So, do they have common points, intersection points? To find it algebraically, you equalize them to one another. So x over 2, x squared equals to 2, square, right? X equals to plus minus 2. So you have minus 2, you have plus 2, right? 2, 1, minus 1. Okay? The intersection point here is 1, 2, 1, and here is minus 2 and minus 1, isn't it? Yes, it is. Third one. Draw the graph. Y equals to 4 on the power of x. So, if your x equals to 0, it will be 1. Actually, you know, a on the power of x equals to y, it will always pass through the point of 0, 1. It will always pass, irrespective of a. Because if your power is 0, it will pass through the 1, okay? It will be 1. A on the power of 0, any number with the power of 0 is 1. That's why it will pass through 0, 1. If your x equals to 1, it will be 4, so something like that. You have asymptote here and below it. B part, so this was A part, B part. Third one, right? Y equals to 2 on the power of x plus 1. We have already drawn the line of it, right? 2 on the power of x. You just raise it by one step, 1 unit up, okay? This is y equals to 1. It can't reach to 1. Why? Because it can't be 0, right? It will always be minor, 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 but it won't be 0. It will be higher than 1. Higher than 0, but this function will be higher than 1, okay? So it was third. Let's look at fourth one. Solve the equation. A. 2 on the power of x plus 3 multiplied by 2 on the power of x plus 2 equals to 6.5. So let's take 2 on the power of x out of the bracket. From the first one you're left with 1. From the second one, 3 multiplied 2 on the power of 2 equals to 6.5 is 13 divided by 2. 2 on the power of 2 is 4 multiplied by 3 plus 1. 13, and there happens cancellation. 1 over 2 is 2 on the power of minus 1, 2 on the power of x. Your x equals to minus 1. B part. 2 on the power of x minus 1 plus 2 on the power of x minus 2 plus 2 on the power of x minus 3 equals to 448. And if you are taking 2 on the power of x minus 3 out of the bracket, what you are left with from the first one, Farangis? 2 on the power of 2. Yes? Ilham, what you are left from the second one? Yes, 2. From the third one, Malika? 1. 448. What is the sum? 7. And there happens cancellation with this one. What is the result if you divide it by 7? 64, right? So 64 is 2 on the power of 6 equals to 2 on the power of x minus 3, and your x equals to 9. Right? 6 plus 3 is equal to 9. Let's turn to 5. Solve the equation. 5 on the power of 3x plus 9 multiply 10 on the power of 3x equals to 10 on the power of 3x plus 9, 5 on the power of 3x. 9 times here and 1 time here. So if you negative 8 times of 5 on the power of 3x. Here you have 10 on the power of 9 times here minus 1 time 10 on the power of 3x multiplied by 8. There happens cancellation. And your x equals to the order. Which number? Zero, yes. Let's turn to 6. 5 on the power of 4 modulo of x minus 2. 5 on the power of minus 3 modulo of x minus 3. Less than or equal to 5 on the power of 11 minus modulo of x. So here you have same basis. You can drop their basis, right? And the sign will not change. 4 modulo of x minus 3 modulo of x. You're left with modulo of x only. Minus 2 minus 3 minus 5. Less than or equal to 11 minus modulo of x. Modulo of x turns to one side and change the sign, right? Modulo of x twice. Less than or equal to 11 plus 5 is 16. So you are dividing by 2. It becomes 8. And your x falls within the interval starting from minus 8 till 8. So both included, okay? What about 7? What about 7? Under the root of 5 divided by 3 on the power of 2x cubed, I guess, x squared minus 5x equals to 1.8. So how to change it? 1.8? 1.8 is 9 divided by 5. And it is 3 divided by under the root of 5 squared, right? And you see their place are changed. How can you change it? By negativating your power, right? Under the root of 5 divided by 3 minus second power. So bases are the same. You drop them and equalize their powers. 2x squared minus 5x minus 2 equals to 0. What is your discriminant value? So it's plus, right? Your discriminant value is 25 minus 4 times of 4. 16, it's 3 squared, right? 5 plus minus 3 divided by twice of your a, 4. Your x1 is half. Your x2 is 2. Yes, if you multiply them, you get 1. If you add them, you get 2.5. Have you understood it? No questions left? So the rest is your home task, okay?